All right. So on this worksheet, give two other names for line P. So line P, you could call it line US, line NS, line US. Any three of those points you can give, and make sure when you call it a line, you put the line on each side. Okay. Name the intersection of planes W and Y. So the intersection of two planes should be a line, so it's line ER or line M or line CE or line CR. Yeah.
Can you do it with three letters? So CER?
It's fine if you do. It's not necessary to do it that way because you only need 2 points to the line. Yeah.
Can we just put the letters? Do we have to have like the line segment line over it?
You should have the line thing over top of it. And with that, it could be the intersection. It could be a line segment RE if you wanted to, or you can just say line CE, line CR, line any combination of 3 letters or just line M. Number 3, name a point collinear with RE. Name a point collinear with RE. C works for me. Name opposite rays. So you could go ray ER and ray EC, or you could say ray NU or ray NS with those 2 different lines. So, and remember the ray, the first letter indicates where it starts. Name a line parallel to line P. That's a trick question because we cannot assume that the plane and that line are parallel to each other. So I think that's a trick question. I think it's kind of bad. I won't do that to you on a test. But there's not one that we can give. Give 2 other names for plane W. Plane W, just using 3 letters. So you can say plane BGE or BGR or REG or REN or something like that. Some of those 3 letters. Yep.
You do just one letter?
Please pardon this interruption. This is just a notification that the network and all the phones are currently working again. Thank you.
Pretty sure the kids discovered that before.
Yeah.
It's back on! Look, it works, it works!
Can you do it with one letter? Like, just plain G?
I wouldn't do that because that W is labeling it plain W. It's not indicating the point. G is a point. Okay. Cool. Name the intersection of plane W and line P. That would be point N. Got it right? Determine if each statement is true or false. Remember to consider what assumptions we did in our diagrams. G and O are collinear. That's true. There's exactly one line. I'll go through those 2 points even though we don't have it drawn. Point ORS. Those are. Someone said this was kind of nice, and I thought this made sense. If you can draw a triangle with the 3 letters, then there's a plane that goes through it. What do you think? You can't draw a triangle through collinear points, can you? No, but if you have 2 points that are on one plane and the third point, if you can make a triangle, then you can create a plane. And then line P is perpendicular to plane W. I don't think we can justify that. We don't know if I don't think there's enough information because it doesn't have to be perpendicular. That line P could be tilted a little bit. So even though it looks like it, don't just trust your eyes. You'd have to have some other indicators to go with that. And points COS are collinear. COS, I don't think so. I'd say coplanar. It looks like they kind of are on the same line, but it looks like O might be shifted a smidge above it. So that's what this worksheet is. We good? Yes.
What was 9?
P is perpendicular to W. I'd say false. 9. ORS or coplanar, yes.
8.
True. Any 2 points, exactly one line could go through those. All right. Let's do some notes. This is from 1.4. And I'll also review me do 1.4 and then we'll cover this review. 6, 4, and 5. Alright. So let's do this. On the back side of that sheet that I had given you that we started reviewing on, if you have space, yeah. What? The one I just handed out? Yeah. I didn't count enough? Or someone hogging them again? You have enough now? Count right in one row, count too many in another row. Alright. So, back side of the review sheet I had given you. Still with me in this story? Back side of the sheet I had given you last night. Still with me? Let's do a quick review, run through what these reviews are up here, and then we'll get to our notes of our information. Sound good? Alright, I don't want that anymore. Putting that there. Alright, so review. So we know that FGI is 3x plus 2. That's that angle. Then this angle here, HGI, is the whole angle. So that would be 7x plus 8. And then we know that, find HGI. Somebody is vibrating their phone's going. Isn't it? Yeah. All right. I think by using the, how do you think? I think if we subtract the two from each other, we'll get the third angle. So this angle here, if I were to take this and I were to subtract this, hey, why did I put that in parentheses? Algebra folk. Yeah.
So it's like the original yada yada, and then
Did he just yada yada me? Okay. Yes, I agree. Yes.
Wait, why are you subtracting?
Because the whole angle is this.
Yeah, I know, but you're subtracting it from that angle.
Right. And that'll allow me to get this blue angle.
Oh, I was seeing. Never mind.
So,
Yeah, I was looking
here,
at it differently.
let me, does that work? Okay. All right. So, distribute here and here. 7x plus 8 minus 3x minus 2. Do you agree? 4x plus 6. So 4x plus 6 would be the size of this blue angle. That okay? Yo. Question back there, black hat.
Wait, so it says HGI is 7x plus 8. Not it's.
Oh, dude, wait. Hang on. You know, I shouldn't come to school when I have a cold. Let me just erase. Nothing to see here. Verify the internet's back up. Okay. FGI is this. 3x plus 2. HGI is this. 7x plus 8. Find angle HGI. Okay. We can do this. This is a far simpler method. What do the two angles have to add up to? 180? Okay, this is so much easier now. Jeez, I'll tell you. That fall off that ladder wasn't as far as I thought. So if I add these together, I'm sorry. I think he's serious this time. Yeah. 10x plus 10 equals 180. 10x equals 170 by subtracting 10. X equals 17. Question?
It's 180 because the line, the FGH line is.
It's a straight line, yeah. Straight angle. All right, so if we find x, we have that, and then if we want to find HGI, we're going to take the 17, plug it in here. Somebody with a calculator could probably do this a lot faster than I could do it. Use a calculator. 119. So we got a calculator and multiply it out. We're saying 119. I just want verification. And then the other angle would have to be 119 plus something to get you 180. That'll work. Can I move off that one?
We have to do that. No, we have to add 8.
Oh,
17 times 7 is.
okay. Again, that's why I said use a calculator, please. So 127. 127 degrees. It's got to add 8 to it. Shh. A couple of you are talking too much. That's kind of rude. All right, so 127 is that angle. If we want to find the other angle, 180 minus 127. 53, but it didn't ask for it, so let's not worry about it. All right, move down a smidge. Excuse me. All right, they tell us that PJ bisects RPQ, so it cuts it in half. So that if this is the case, that means that this angle here and this angle here have to be equal to each other. So then they tell us that RPJ is 4x minus 2. And then we know that JPQ is 3x plus 18. Find RPQ. Well, what do we know about the two angles right now? They're equal to each other, so let's figure out what x is, and then we can figure out each individual angle by plugging it back in. All right, subtract 3x, so I get x. Add 2, so I get 20. So this is 78 degrees, and then this would also be 78 degrees. And if I add, and then we want to find RPQ, so that's the big angle. So 78 plus 78 is 156.
No.
No?
One.
I think it is 156 degrees. I think.
Wow.
Everyone good with that? Woo! Let's see how many pages this is. Probably 7,000. That's actually. All right. Now this goes along with our notes, I believe. Oh, it was on that review sheet too. All right. No biggie. All right. Chapter 1. More angle relationships. Develop an understanding of complementary, which is 90 degrees. Supplementary, which is 180. Vertical angles, which are always equal. Linear pairs, which are two angles that go to become a straight line. And then, yeah, this is the right side on your sheet that I passed you off. And then perpendicular lines are two lines that cross each other, forming 4 90-degree angles. Sound okay? Now the air is on. Now I'm getting nice and cool. Must be the window cracked in the background. Can I move on? Perpendicular. They tell us that AB is perpendicular to CD. That all they tell us, or is there something hidden up here I'm supposed to find? You guys think? Anything there? So if they're perpendicular to each other, it just means that you form 4 90-degree angles. You only need to signify one of them is 90. Yeah. Yep. You never have to ask. Just go. Question? Over here. So 4 90-degree angles that you sum up would get you 90, 90, 90, 90, which is 360 degrees. That didn't happen by accident. That should go. Okay, so given angle AB is perpendicular, so they use the upside down T, to BC, there is something I can pull out right here. Since they have the same measures, what can we say about angle 1 and angle 2? They are supplementary. What else can we say about these two angles? They are congruent. They happen to both be 90 degrees, but 90 equals 90. Duh. Is that all right?
Hold on.
Hang on. Talk to me.
How do you know that
two lines are perpendicular, it means it creates two 90-degree angles. So what are a measure of angle 1, what are a measure of angle 2? 90 and 90.
So did you say those two would be supplementary?
They would be supplementary. They also form something called a linear pair, but we're not there yet. May I move off that? Here we go. We just proved a theorem. Oh, yeah. Okay. Do I touch the balloons? Nope. There's volume there, but I know that my speakers aren't hooked up right now. Theorem 1.1. Okay. So theorem 1.1. If two lines intersect each other, they form two 90-degree angles, which means the two angles are congruent to each other. So theorem 1.1, we could note, say this any way we wanted to. I would just say it goes along with this. If you knew that A, B, C, D, get the letters, Chris, you can get there, you can make it work. AB is perpendicular to CD, so angle DBA has to be congruent to angle CBA, which then means that you get 90 is equal to 90 for each of those angles. That's what they equal. That's basically your theorem 1.1. Can I move off there? I like the bouncing balloons. It's fun. Adjacent angles. Two angles that are next to each other. Two angles next to each other. That share a common side. What's the common side of the diagram? Yeah, this is my common side right here. Okay, so that means that angle RGI and angle IGN, they are adjacent angles. They are next to each other. They share a common side, or a common ray, or common segment. I think that's all the doors I have. Feeling all right? Moving on. Make sure there's nothing left to find on here. Nope. Complementary angles. You've heard this over and over and over again. Two angles that add up to 90 degrees. So two adjacent angles that add up to 90 degrees exactly. Okay? Question? Do they have to be adjacent? No, it really just comes down to two angles that add up to or sum up to 90 degrees. So angle 3 and angle 4, if they form 90 degrees between them, those are complementary angles. And then angle 1 and 2, where you have the adjacent side in there, or you have the shared side in there, it's good to go. Supplementary angles, give it a shot. Two angles that sum up to or add up to 180 degrees. We got a 3-day weekend this weekend. That'll be good. Any of you hear about the doctor who spoke this morning?
What?
Every kid in the class took a picture of him. Anyone know why? His senior prom, Hillary Rodham Clinton was his date. He grew up 3 streets away from her, their childhood friends. All of a sudden, all the kids heard that and said, "Dude, clank," and took his picture. And some kid looked online and he goes, "Here's a picture of our prom picture. Is that you?" He goes, "Yeah, that's me." So, whether your family is voting for her or not, I don't know, and it's not my business, nor is your business if I'm voting for her or not. But I think I'm writing in Mickey Mouse this year. Come on, Mickey, Mickey, Mouse. But I still think it's kind of cool that, wow. Vertical angles. Okay, this is a vertical angle. Here and here. Vertical angles are equal to each other. So they are across from each other. And are equal. Or congruent. So before you ask, is this and this, are those vertical angles as well?
Yes.
Yeah. So vertical angles happen as two lines cross. They share the corner. Okay? And vertical angles are always equal. So anytime you have two lines crossing each other, you create vertical angles, and you know that that's an automatic go-to. Can I move on? Anyone stuck? Linear pair. My opinion is this, and it doesn't really count. I think they just need to get rid of the term linear pair. Because linear pair looks like what? It's like 180, it's like supplementary angles. Okay, I really think that, it's two angles that when you put them together makes a straight line. Well, a straight line is a straight angle. Straight angle is supplementary. I feel, and I might be completely wrong, that linear pair and supplementary angles might be able to be used interchangeably. Okay, so hang on. We have two angles. When put together, makes a straight line. Forms a straight angle. We wanted to say that. Spell everything right? I wrote a lot. I might have tons of misspelled words up there. Straight angles 180 degrees. Two angles when put together add up to 180 degrees. Oh, they're supplementary. Oh, wait, are they a linear pair? Or are they supplementary? Yes and yes and yes. I think they all go along with each other. We doing okay so far? Hey, we got a quiz tomorrow, huh? That's going to be exciting. That'll be fun. Yeah.
Is this stuff gonna be like this?
Today's stuff, no.
Okay.
Ready? Boom. Examples. If angle 1 is a complement of angle 2, and measure of angle 1 is 17, find the measure of angle 2. Ideas? Yeah.
90 minus 17.
Yeah. We're going to go 90 minus 17. No applause, just throw money at that kid. And that's going to get me 73. Okay? 73 degrees. Feel all right about that? If angle 3 is a supplement of angle 4 and measure of angle 3 is 119, supplementary angle is how much? 180. Minus? Excuse me. Can we do that? 61? Is that right? So I guess the geometric way of doing this is we could do angle 1 plus angle 2 equals 90, for the above. And then we could say that 17 plus angle 2 equals 90. And then this one you say angle 3 plus angle 4 equals 180. Being that angle 3 is 119 plus angle 4 is equal to 180, and then solve that. So Using algebra as well to solve it. Yeah.
When you're showing your work, is it okay if we just put 90 by 17?
All day long, right? Even you. Sorry. He was the one who asked, so he gets special privileges. Give him a hug, would you? Can I keep going?
I don't know, can you?
All right. Identify. Ooh, this is a toughie. Identify the vertical angles. Angle what and angle what are vertical angles? Yeah. 1 and 3. So angle 1 and angle 3 are vertical angles. Now, someone might be able to argue saying, well, angle 2, and if I sum together angle 4 and 5, those are also vertical angles. True, I'd say that this and those two added together are equal, but you really have to be able to identify vertical angles right away. And then identify 2 linear pairs. So is that a linear pair?
Yep.
And then is this a linear pair? Feeling okay? There we go. Huh. Excuse me. I hope this cold goes away. Hope it's not one of those that last 15 months, like a bowling season. I don't know if you ever bowled. 237 weeks. Oh, that's long. Yeah.
Could 5 and 3 be linear pairs?
5 and 3 are not linear pairs because a linear pair is pair, meaning 2. So you can't say 3, 4, 5 form a linear pair. Though 3, 4, and 5, if you sum them together, would equal 180. Yeah. 2 and 3, yeah. That's why I did the pink dotted. Cool? All right, can I move on? Or may I move on? I'm moving on regardless. Right angles, what do you think? And it's not just angle E. So I say GEM is one of them. Someone shout out another 3-letter one. MET. What else? What? TEY. Okay, and the last one? GEY. GEY, TEM, MET, TEY. Is there any others that we could go with? No. I mean, it's very possible there might be others, but you just know that the 2 lines are perpendicular to each other because you have that little dotted box. What about the vertical angles? Shout out 3 letters of vertical angles. Wait. Oh, what? O-E-M and? So O-E-M and Y-E-R. Okay. Are there others that we can shout out? Is this and this? Okay. What about this and this? Yeah, if we eliminated that line right there, and now my arms are all in the way, there's an awkward shadow and stuff like that, and people are just looking at the back of my head. You know what frightened me the other day? When y'all decide to have families, it's amazing how honest your kids will be with you. And y'all might, so my youngest, May, she's a great kid. You guys would probably think she's a pretty cool kid. She says to me, Dad, you have a lot of hair back here. And I was like, where? And she's like, right here. I'm like, oh. I thought it was just here. No, apparently it's here too, but she was able to point that out to me. Yeah, May is my sarcastic kid. She has my sense of humor. You know how I knew that May was my daughter? Well, I mean, for obvious reasons, I understand how she is, but when she is like 5 years old, and now she's older, we were walking through a grocery store, and there's a gentleman who's got a short shirt on, so he's bending down, so he looks like he's portraying a plumber. And she goes, hey, Dad. She's my kid. So I thought it was funny. Sorry. All right. What? Oh, yeah, here we go. What? If you guys didn't figure it out yet, ask your neighbor. They'll tell you what my daughter tells me. What's the complement of x? Any ideas? Yeah.
90 minus x.
Oh, I love it. 90 minus x is absolutely right. Why do we know that? Because if I were to take 90 minus x and add x to it, I get 90. That refers to a complementary angle. What is the complement of x plus 20? Well, I'd say it's got to be this, 90 minus x plus 20. Agree? And that's 90 minus x minus 20, which is 70 minus x. Good. Love it. Can I do the same thing with letter C? Okay, so 90 minus, where do you think the error takes place on this type of problem? That negative over the parentheses.
Yep.
It's so forgotten. And it's like, yeah, you have the thought process, but you're not showing it. So make sure you understand the math that's taking place. So then that's 105 minus x, if we worked it out. What's the supplement of each? Help me out. 180 what? I like it. 180 minus x. Sweet. What about the next one? 180 minus? Good. I like the parentheses. Distribute. 180 minus x minus 20. Was that 160 minus x? Sweet. Yeah. You guys are awesome. I don't care what I ever said about you the other day. You guys are awesome. What'd you say about us? Didn't say anything bad. Sweet. I totally am starting to get this stuff. Good, you're the teacher, you dork. Okay, you're right. Where are we at on this?
We're done with the notes.
Do what?
We're done with the notes.
We're done?
Yeah.
Yes, sir.
Are you kidding? I got done early?
You finally finished one.
Dude, what did I do right or wrong today? Yes, ma'am.
Oh, never mind. That's
So there'll be a quiz tomorrow. The quiz will be 1.1 to 1.3. I have allowed you, if you wanted to, hang on to those last couple of review sheets. You can, but I'll collect them tomorrow. I haven't put anything in the grade book yet, so don't feel like, oh man, I'm missing out. Let's see. We are going to actually, and I'm just going to give you guys a heads up, guys and girls a heads up on this. We are going to start, not starting tomorrow, but we will start eventually having 2 portions of our quizzes. We'll actually have some that will take place on Schoology that could be a take-home portion. Okay? But we're going to start. And I'm not starting yet, so don't be looking for it yet. But we'll do stuff on Schoology, and I'll show you the stuff at the end of the year that we got to do with Schoology once we're done with the class, which is actually kind of cool for a visual perspective of stuff. Hey, you guys were awesome today. What did I do right or wrong to deserve this class? Yeah. Nope.
Oh, no, I was asking about this.
Oh,
It's a review. It's just 1.1 to 1.3.
sweet.